Hi, my name is John and this is Business Focus. In today's video, we'll be talking about simulation modeling. So let's get started. And we're back. In today's video, we'll be focusing on what simulation and how can you do simulation modeling using Excel. Now, to be able to do that, one has to understand what simulation is and what it can do for you, especially in an organization in terms of making decisions. And in terms of making decisions, we want certainties in lives that it helps us make better decisions every time. But in reality, there are more uncertainties that we deal with than we'd like to expect or understand. So, in terms of business or even in government, how can we understand, use that uncertainty to our advantage here? And one of the tools in analytics is using simulation here, and one of the more popular simulation tools is the Monte Carlo simulation here. So it uses or it evaluates the impact of uncertainty based on your decision here. And obviously the simulation is a very powerful tool once done properly in a variety of disciplines here, in terms of in operations, understanding demand, profit, or even in finance, making investments, and even marketing, which products to push and so forth. Now, there are 4 key steps in simulation modeling, so we'll go through it step by step. So the first one we'll be doing is creating a spreadsheet model here. Now, if you're not familiar how to create a spreadsheet model, I do strongly suggest you watch my previous video how to create a spreadsheet model to give you an idea here. So the point here is to create a parameter and a model here. So the parameters are the given values or the different variables that is provided here. Then the model part is the formulation, where the output or what you're looking for here. So we'll use a basic example just to illustrate here. And next is step 2 is to identify the type of distribution you're going to utilize to understand or simulate based on the uncertainty here. And third is to conduct simulation trials based on those distribution to find out different outcomes here. And then fourth and final step is to analyze and measure the simulation output, see if this is beneficial for the business or not. So here we have an example to illustrate that. So let's take a closer look. As you can see here, we have a sample problem here. So it's a basic spreadsheet model here. So that's step 1 in simulation modeling here, is to create the appropriate spreadsheet model. So that includes creating the appropriate parameter, the given variables, inputs, and your outputs for your model here. So we'll use the basic profit model to illustrate this simulation problem here. So to be able to identify the profit here, you need to have the following variables. You have the selling price, fixed cost, labor cost, material cost per unit, and quantity here. So to be able to determine profit, so we need to determine first total revenue here. So we simply multiply quantity times the selling price here, and we get 50,000 here. Now for total cost, so that's fixed cost plus your variable cost. So let's start with the labor cost per unit times quantity, close parentheses, and add your other variable cost, which is material cost times the quantity again, close parentheses, and you have 115,000. So to get profit, you simply subtract total revenue with total cost. So as you can see here, you can see that you will lose 65,000 if you produce only 1,000 units based on the different variables that you're given earlier here. Now, obviously, these are certain outcomes or certain variables that take into account in any problem. But in reality, it's much more complicated. There are a lot of uncertainties here. So we'll use the 3 variables here to illustrate how to implement simulation with the different distributions here. So let's assume for the labor cost here, and for material cost and quantity. Okay. So step 2 now is identifying the different distributions to be applied in this particular problem. So for labor cost, let's assume it's a discrete distribution. I'll explain in a bit how to construct the table for this one. Next is for material cost. Let's assume it's a uniform distribution, since the pricing for your material cost is between a certain range. And finally, for quantity, we'll use normal distribution here. Okay. So the key here now is how do we formulate it so we can find randomized value here. So we're going to do that. So we'll copy first the selling price and the fixed cost. Okay. So the first now is to create the discrete distribution here for labor cost per unit. Okay, since it's a discrete distribution. Okay, so we need 4 columns here. So you need to create the lower and upper limit. You need to create the column for the cost per unit as well as the probability here. So type in lower limit, you have the upper limit, and then you have the cost per unit and the probability. So to start off, we need to determine what are the different costs per unit. Now, given in our problem is only 10 bucks here. Now, that may change or vary depending on the situation here. You could find a lower cost or a higher cost depending on the situation here. So let's say you are able to find a cheaper alternative, labor cost, that's 5, 8, 10, 12, and all the way to 15 here. So it could vary here. Now, the next thing here is identifying the assigned probabilities for each of those costs per unit. So again, there are 2 ways of determining the probability. It's either given in the problem or it's based on historical data, which is given as well. So let's assume for this scenario, it's 0.1 for probabilities or 5, and then you have 0.2, 0.4, 0.2 again, and 0.1. Now, make sure that if you add all of your probabilities that they are all equal to 1. So it's correct. So we can now move on in creating the limits here. So for the lower limit, we'd always start with 0. And to get the upper limit, you simply add the lower limit and the probability on that particular row. To get the second row, the lower limit, you just highlight the upper limit of the previous interval. Okay? And once you've done that, you can simply copy and paste the rest. Okay. Let's try it. And paste. So you can see here, you can see from 0 all the way to 1 here. Okay, so once you've done that, so we can now create the distribution for the others. So how do we find the discrete distribution value for the labor cost here? So you're going to use function formulas here depending on the type of distribution. So for discrete distribution, we'll be using the VLOOKUP function that would help us identify what is the value here. So to do that, so type in VLOOKUP. Okay, and you're going to be asked several items. So the lookup value, we're going to use the function random value. So rand, open close parentheses. Then for the table array, simply select the lower limit, the upper limit, and the cost per unit. So that first three columns. And then you'll be asked the column index number. So which column do you want it to be displayed? So in this case, we want the third column. And type in true for that approximate match, and then we'll spit out a value here. Okay, now take note, since you use random function, it will change once we move along here, but that's okay. Okay. No pun intended. But anyway, so next we'll go to the uniform distribution here. So to be able to do that, we need to create another table here. So let's go to the next one. So for the uniform distribution, this is for the material cost per unit. Okay, so let's select this, and in this case, the material, let's copy and paste. So in this case, it's a uniform distribution. Okay, so how are we able to do that? You need just simply to determine what's the lower limit or lower bound or the upper limit for the material cost. So lower bound, lower value, lower limit, and the upper limit. Okay, so in our case, the material cost that you got is $5. That's the lower end, and the upper limit is 10 bucks here. So to be able to do that, to create that function, so again, in this case, to do that, we don't need a simple function, but we will use a formula here. Simply get the lower limit plus the difference between the upper and lower limit here. Okay, times the random function here. So rand open close parentheses. Okay, so it would choose between $5 to $10 here. So let's see what we got. So you can see it generate a value between $5 and $10 here. So that's 9.32. And finally, for quantity here, since it's a normal distribution, we need two things here. You need the average or the mean and the standard deviation here. So let's copy again this one. So for the first one, this is quantity and this is a normal distribution. Okay, so we need the mean and the standard deviation. Okay, so let's assume based on historical data that the average mean is 3000 and the standard deviation is 500. Okay, so to find the function here for normal distribution, we simply type in the function norm.ind or inv, and you'll be asked three things: the probability, we'll type in random function again, randomized, and then the mean, we select 3000, and then the standard deviation is 500, and then we'll see the quantity here. So it can vary here. So we're going to do simulations later on, which is step 3 here. So you can see here we have based on the different inputs here in our parameter, it gave us different outputs here or different values here. So let's find out what is the total revenue here. So quantity times the selling price. So it's wait, let's put some commas here so we can see it. Okay, so it's a little over 100,000. Now for total cost here, so it's fixed cost plus the labor cost plus the material cost times the quantity. Okay, and if we were to get the difference, what's the profit here? So you can see here, based on the random function here, you're losing 26,000 bucks here. So it's still negative values here. So we've now created a spreadsheet model. Step 1, we've already identified the different distributions here. Step 3 now is creating or conducting the simulation trials here. Now there are different rules of thumbs here. Now obviously for our purposes here, you can do as little as 10 trials or even as many as 100 trials, but for our purpose here, we'll do 1,000 trials here to see if there's any significant results that we can take away from this one. So to create the simulation trials here, we need to create several rows here, or several columns, sorry. So we need first to create the simulation trial column. Okay, and then next is incorporate the different variables that we have assigned random functions here. So we have the labor cost, that's one. You have the material cost, that's another. And then you have quantity as another. And finally, based on the different inputs, what is our profit here? Okay, so now as I mentioned, creating 1,000 trials may look daunting, but there's a trick way or tip here that you can expedite the process here. So let's start with the first simulation here. Then you put in the formula, then you just go down so until you reach 1,000 here. So let's see if we get here. Okay, so we're able to do that. Now obviously it would be a tiring process if you have to keep on flipping back and forth if you're going to fill up the rest of the other columns and analyze it later on. So to do that, so we will shortcut this, or trick here is by hiding the other rows that we don't need to see, so we can see it in one spreadsheet here. So I will simply select from the 11th simulation all the way to the 999 simulation. So we'll hide this, and you can see here from the first simulation all the way to 1,000. So we can see it clearly here, so it's much easier to understand. Anyway, so to fill in the rest of the rows, for the first simulation, we'll repeat the same formula as mentioned that we did earlier. So we'll use VLOOKUP for the labor cost since it's a discrete distribution. VLOOKUP, sorry. Okay, so random function, table array, select the tree again, and you want to display the third column, and type in true. Now, to expedite this also later, we'll lock in the cells here so we can do the run easily. So I'll show that trick later on. Okay. Wait, did I type in? Mistype the function. So it's random. Okay. So in this case, the random value for labor cost is $12 here. Now for material cost, again, since it's uniform, you just get the lower limit plus the difference between the upper minus the lower times the random function. Okay. So again, we need to lock this so we can select it. So type in F4 so you can lock the cells here. Okay. And then for quantity, since it's a normal distribution, so we type in norm.q, sorry. Then the probability is random function again. The mean is 3000 and the standard deviation is 500. So you want to lock the cells again, as I mentioned. Okay. Close parentheses. And we get this. And then finally, for the profit here, so to get the profit, you just add the total revenue and your total cost here. So in our case here, based on our selling price, you subtract your labor cost minus your material cost times the quantity minus your fixed cost. Oops. Wait. Made a mistake here. Let me do it again. I was supposed to use the first row here, not the under column D. So let me try it again. So the selling price is still correct. Minus your labor cost here, minus your material cost per unit. Then close parentheses, multiply the quantity, and then subtract the fixed cost. And based on our first simulation run here, we get a loss of negative 5,000 here. Okay. So now we're going to do 1,000 runs here. So to expedite this, rather than repeat the formula here, here's a great trick or tip here. So once you have locked the cells here, so you notice the dollar signs in front of the row and the column for the material, labor cost, material, and for the quantity, and even for profit. So we have to lock it. So the lock is for the profit, okay, and for the fixed cost. Okay, so let's put in some comma, and then let's put in highlighted if it's negative 0. Okay, so we simply highlight the entire row and then go to the lower left corner in under profit loss. You can see a plus sign in the corner. You simply double click that and it will automatically fill out the rest of the columns here. And you can see here it varies here. So you have a different labor cost, different material cost, quantity, and what's the profit here. So that's step 3. So we've already covered creating a spreadsheet model, which is what we did here. Okay. And the next now is creating the appropriate distributions. Okay, based on the given distributions, we have to create the appropriate tables. Step 3 is now creating the simulation trials here. So we've conducted 1,000 simulation trials here. Now the fourth and final part is the most important part. So based on the simulation trials that you've conducted, we need to identify what is the result, what analysis can we take from this simulations here. So we need to create a table here. So we need to summarize, or the summary for your profit, summary of profit. Okay. So to create the summary, we need several things here. So let's start first with count. Okay, so to count, literally count. Okay, select the function count and highlight the column under profit and loss, and it will count how many count it is. It's 1,000. And then the next part now is getting the average or average profit. So what's the average profit? So type in the function formula average and select again the column here. And if you enter that, you get an average profit of negative 2,500 here. And we also want to determine what's the standard deviation of profit. Okay, so type in stdev.s for sample, and again select the profit loss column, and you'll get 19,000. So it deviates that much. So let's move this a little bit. Okay, and next we need to determine what's the maximum profit and the minimum profit. Maximum profit. So the function formula for that is max, and then select the columns again. For the minimum profit, so type in the function min, and then select the column again. And lastly, the most important part. So as a business, your goal is to make profit here. So you'd like to find out what's the probability that based on the simulation trials here, based on the given variables that we've discussed earlier or utilized, what's the likelihood that we'll be making money or versus we'll be losing money here. So we'll type in probability that profit will be less than 0. So to do that, we'll use COUNTIF function and count here. So for the COUNTIF function, you get the range. Okay, so you select the column again for the profit, comma, the criteria here is if it's less than 0. So it's going to count how many of those simulation trials have less than 0 profit here. And then close parentheses, and then divided by, count again based on the row in the profit. So close parentheses, and we can see here that there's a 53 chance of losing money, which is not good here if you own this type of business here. So that's why the summary here is so critical here. So let's put it inside of the box. So not only that, we can also visualize the results here by creating a frequency table here. So by creating bins and frequency. So let's create some bins and frequency here. So to create the bins here, so that's why you created the try to determine what is the maximum and minimum profit. So you can see it's as low as 55,000, as high as 58,000. So let's use negative 100,000 here. Okay, and intervals of 50K. Okay, so wait, sorry, my mistake. Okay, and let's end all the way to 150 here. Okay, so once you have the bins already set up, the question now here is how are you going to create or construct the frequencies here. So let's move it closer so you can see better. Okay, hopefully. Now let's delete this column. Okay, so the frequency here is very simple. Simply select the missing frequencies here and type in the function formula frequency. Okay, and then you'll be asked to select the data array. So simply again select the column under profit and loss, and then the bins array, which you already constructed, select them, then close. Now normally you would only press enter so that you'll get the frequency for that particular row. Our goal here is to populate the entire frequencies here from top to bottom. So the trick here is typing in the keys Control, Shift, and then Enter, and then it will populate it automatically. So you can see here, since it mentions that there's a 56 chance of losing money, you can see here, majority of your frequency is between or in the range of 0 or less, which is not good. Now we can also create the percent frequency here. So by simply dividing the count here, let's lock the cell. And you can see here also, so it's 55% chance, so it's not that good. So obviously the resulting here, despite all of the simulation runs that we've done here, as a decision maker, we can see here that this is not good for business. And obviously if we were to visualize it with a histogram here, so let's insert. if we have a histogram here, so let's add the axis title, remove the grid lines. So for the y-axis you have the frequency, and then for the x-axis you have the bins, and lastly we have the title histogram on profit. Okay, and then we have to change this into a histogram, and voila. So obviously, in terms of the interval of earning 0, a high likelihood, which is not good for business. So question is, as a decision maker, what changes should we make to change the outcome here? So first thing that comes to mind here maybe is increasing the price, or maybe increasing the production or selling more units here. So if we were to change the average mean here, so let's say it's from 3,000, let's make it 4,000. Let's see if there's a change in the outcome here, and you can see dramatically. So from as high as almost 50%, if your average quantity or demand is only 3,000, to changing it to 4,000, it dramatically changes your probability of losing money to as little as 6.5%. And you can see here, majority of your profit you'll earn on average 50,000, which is not bad. Now, if that's your goal, if you want to earn more, obviously certain parameters has to be changed here. So the sky's the limit here based on the situation here. But the simulation here, example here, illustrates how powerful simulation modeling here is. Now, there are different more applications that we could utilize here, but this is just a glimpse of as to what you can expect in conducting simulation using basic Excel here. So if you can do this in in inventory, in production, you can do this in other aspects in your organization, in finance, marketing, and as well as advertising here, which is pretty powerful if you think about it. And stay tuned for more if when we create more videos regarding this one. So anyway, I think that concludes our video for today, and if you find this video helpful, don't forget to hit the like and subscribe button. So please help support the channel. Also, you can leave your comments down below if you have any question regarding today's video, so I can I'll try to get back to you as soon as I can, humanly possible. And if you're interested, you can check out for more videos, check out my other contents in the channel. Anyway, thanks for watching. As always, I'll see you in the next one. Take care.